Hi, you're welcome to today's class. Today we'll be dealing with separation of mixtures and purification of chemical substances. Before we proceed, let's find out what is the definition of a substance. A substance can be defined as a particular kind of matter with uniform properties. We can also define a substance as a physical material from which something is made. A substance could either be pure or impure. What is the difference? A pure substance has a constant chemical composition. Pure substances are composed of a single or atomic type of particles. They possess a constant structure. A compound can also be a pure substance. A compound is a pure substance when it is combined chemically in a fixed defined ratio. Examples of pure substances would be ammonia, water, baking soda. An impure substance, on the other hand, is composed of several elements that are mixed, that are put together in a non-fixed defined ratio. So, examples would be muddy water, salad, salt, a mixture of salt and water. Now, when we have what we have over here is an organogram to show us a pictorial view, a tree view to show us everything, to give us an overview of what substance is and the various types. We've defined what a substance is, and now we said a substance could either be pure or impure. For the pure substance, we could have elements, and then they could also be compounds. What's an element? An element is basically a pure substance that is made up of only one type of atom. Example, you could have iron, Fe, which is represented as Fe, or copper, which is usually represented as Cu, or hydrogen or oxygen, as the case may be, and so on and so forth. Compounds, on the other hand, they are pure substances made up of two or more different elements. For example, water, H2O, which is a combination of hydrogen and oxygen in a fixed defined ratio. The same thing goes with sodium chloride, NaCl, which is what you probably know as your table salt. This is also a compound because it is combined in a fixed defined ratio. For impure substances are basically mixtures, and these mixtures could either be homogeneous or heterogeneous. A homogeneous mixture simply means a mixture with uniform composition throughout, while heterogeneous mixture is a mixture that has a non-uniform composition throughout. Now, impure substances could be made pure substance through diverse means. One of which is basically through separation techniques. But before we delve into separation techniques, we would have to define some certain terms, which will commonly come up whenever you're trying to separate or whenever you're trying to turn an impure substance into a pure substance. Melting points, boiling points. These are terms that may come up, when we're dealing with the transformation of an impure substance to a pure substance. So when we say melting point, what do we mean by melting point? Melting point simply refers to that temperature at which a substance transitions from a solid to a liquid state. Melting point, I repeat, it simply refers to that temperature for which or at which a substance transitions or changes from solid to liquid state. The solid and liquid phase are in equilibrium at the melting point. The boiling point, on the other hand, is that temperature that for which a liquid's vapor pressure equals or becomes equal to the pressure around it. So at the boiling point, the liquid transforms into vapor. Now, this basically could bring about different kinds of changes. We have physical change and we have chemical change. A chemical change results from a chemical reaction, while a physical change, it comes about when matter changes its form but not its chemical identity. Example of a chemical change is burning, cooking, roasting, and then example of a physical change is boiling, melting, freezing, and shredding. So now let's talk about the separation techniques. There are different separation techniques from which you can separate two or more mixtures or two or more elements or atoms, as the case may be. Now, the separation technique you apply depends on what you're trying to separate and depends on what you're trying to transform from an impure state to a pure state. Not all separation technique is applicable for certain kind of mixtures or compound, as it were. The first separation technique we'll deal with is filtration. Filtration is used when you're trying to separate an insoluble solid from a liquid using a filter. Example, a mixture of chalk and water is a perfect example. Chalk is an insoluble solid and water, in this case, is supposed to be the liquid. So a mixture of these two constituents can be separated using a filter paper. Another means of separation is decantation. Decantation comes in when you're trying to separate a mixture of insoluble solid from liquid, but this time around you allow the solid to settle down or decantate at the bottom. Evaporation is also a means for separation, and this means is used to recover a soluble from its solvents. A soluble will mean a solid that can be dissolved in a particular liquid, and that liquid is referred to as the solvent. A mixture of salt and water can be separated by evaporation. When the water is allowed to evaporate, then the salt is then left behind. Sublimation is also a separation technique, and sublimation is used to separate substances that sublime. A substance that sublime is simply a substance that can change from solid state straight away to gaseous state on the application of heat. Centrifugation is also a separation technique. Centrifugation is a separation technique that is used to separate a mixture of insoluble solid from a liquid using a centrifuge. A centrifuge is a machine that spins the test tube at a high speed. You usually find this in hospitals when a mixture of blood cells and plasma is trying to be separated. Precipitation, on the other hand, is also a separation technique. This separation technique actually depends on the solubility difference of two solids, or of a solid rather, in two different miscible liquid. Distillation has to do with vaporizing a liquid from a mixture, then condensing the liquid to regain it in its pure form. So when you have a liquid mixed with several other miscible liquids, then we vaporize by introducing heat, and then at a certain point the liquid with a lower boiling point vaporizes first, and then once it is turned to vapor, the vapor is captured and then condensed in the process. This is somewhat the same with the separation technique, fractional distillation. But then fractional distillation comes in, especially when you have boiling points of less than 100 that are very close. Boiling point of miscible liquids, usually less than 100, but then are very close. Other separation techniques could be the use of separating funnels, the use of sieving method, and magnetic separations.